Hello, everyone, and thanks for joining us for today's Thorogood hosted webcast, DevOps, DataOps, and Data Factories, the latest trends in BI and analytics. So my name is Alaistair Jones, and I'm joined today in Thorogood's Boston office by my colleague, Amanda Quon. We're both business intelligence and analytics consultants at Thorogood, associates, and our understanding of today's trending topics is grounded in the experience we have delivering projects for our customers. So our overarching objective for today's webcast is that you all leave with a clearer understanding of the terms that represent trends in business intelligence and analytics today, namely DevOps, Data Factories, and DataOps. We're going to begin by introducing Thorogood before we get into each of those three buzzwords and conclude by summarizing today's learnings. So to begin with, for those unfamiliar with us, Thorogood Associates is a specialist business intelligence and analytics consultancy. We focus on locking onto our clients' business objectives and marrying that with our technical expertise to deliver the most effective solutions for our customers. We operate globally with offices in Boston and Philadelphia in the US, as well as in the UK, Brazil, Singapore, and India. We offer a range of services relevant to our niche of BI&A, including strategies and roadmaps, training and enablement initiatives, maintenance and support, in addition to solution design and development. We tend to work across four data-rich verticals: consumer goods, pharmaceuticals, banking, and insurance. We're proud of the close-knit and long-standing relationships we've established with some of the names that you see on your screen. We partner with key technology vendors in our space. Our key strategic partnerships include AWS, Microsoft, Databricks, and Tableau. Once again, we're proud of our close and long-standing relationships that have been established with partners, and we frequently collaborate with them on educational events such as today's. So now that we've introduced ourselves, let's delve into the first of today's topics, which is DevOps. So let's start with a definition of DevOps and then explain and contextualize that definition. DevOps is the philosophy of unifying development and operations at the culture, system, practice, and tool levels to achieve accelerated and more frequent delivery of value to the customer by improving quality in order to increase velocity. So that definition kind of touches upon this, but DevOps impacts an organization's people, processes, as well as their tools and how they're used. Embracing DevOps will mean thinking differently about each of these facets of your business. DevOps ultimately entails bridging the gap between IT development team and operations. This can be challenging since the goal of these two areas are conflicting. The operations team is usually interested in providing stable and reliable services and infrastructure. Therefore, they avoid risks and try to work as predictably as possible. The development team, in contrast, must respond rapidly to changing business requirements and is interested in fast cycles in order to quickly deploy their changes to production systems. DevOps tackles these challenges by establishing a culture and processes that tear down the silos and think more collaboratively. We'll get into a discussion about how to adopt DevOps, but first let's consider the goals and benefits of embracing DevOps. So DevOps allows companies to make changes more quickly and with confidence. Business users can get the results they desire with shorter lead times. Companies that embrace DevOps in its truest sense with automated testing and other robust, repeatable processes can attain a sense of reliability in their systems and their consistency. In a fast-paced business world, responsiveness is a key competitive edge for businesses. DevOps allows companies to respond quickly to business changes, iterate and get feedback from business users as they go, and ultimately deliver maximum value. DevOps enables scalability, with lots of teams feeling empowered to constantly develop, leveraging infrastructure as code or continuous deployments to redevelop existing systems. Another goal of DevOps is to ensure security and that the right people are making the right changes in the right way. But organizations that get this right can feel much more liberated in their ability to operate. Another eventual goal and benefit of DevOps when it's working correctly is enhanced collaboration. There's inherent collaboration between the development and operations teams, but also business stakeholders as business-oriented systems are iterated upon and enhanced continuously. So how do you do it? How do you make DevOps work effectively? Interestingly, recent Gartner surveys indicated that a large proportion of the IT space is interested in DevOps and Agile delivery, with 70% of organizations stating that they're focusing on DevOps and 88% of organizations stating that they've adopted Agile. But then again, only 26% of the firms have adopted testing automation, a key tenet of DevOps. So there's a difference between saying and doing, and I'll look to outline what we consider to be the key considerations when adopting DevOps. Primarily, there's a culture shift required towards the teams managing development of data and analytics applications merging with the teams responsible for delivery and continued support. Design philosophy must be changed so that you're developing systems in a way that they can evolve, adapt, scale, and grow through operations. It's crucial to embrace common practices such as code management, branching, and code reviews. Since DevOps entails frequent delivery, you need to think about your objectives and goals as opposed to specific end scope. It's useful to be flexible to get there. Adopting practices of continuous integration and continuous deployment or delivery are useful, which are the concepts of regularly merging code changes and testing them, and making production changes in smaller chunks as opposed to all at once. This generally makes things easier and allows for incremental value to be delivered. Infrastructure as code is becoming more popular and is a way to quickly define and easily manage data infrastructure. Logging and error monitoring is increasingly important for security when dealing with massive amounts of data, sometimes confidential, and to get immediate feedback, or failing fast on what you're doing. So those are some brief thoughts on how to embed DevOps in your organization. We're happy to provide more detail on any of these points. So DevOps is increasingly popular and can be applied to business intelligence and analytics with careful consideration. Generally, business people want responsiveness. Technology people want to service business customers and alleviate the pains of delivery. Effectively, nowadays everyone is being asked to do more with less, and DevOps can help with that. Some first steps that I expanded on in the prior slide to consider include doing a fundamental assessment of DevOps and how and where it can be applied most effectively. Consider the use of automated deployments, automated testing, disciplined code management, codified cloud environments, and the modularization of requests. We can consult with anyone who's interested in learning more about DevOps and how to apply it to their business's BI and A practices. So feel free to get in contact with us. So with that grounding in DevOps, we're now adequately placed to discuss data factories and then DataOps. Over to you, Amanda.
Thank you very much, Alaistair. All right, so let's pivot from discussing DevOps, which is essentially making development and operations great again, to another process improvement concept called data factories. Now, what do you think of when we use the term data factories? For many of you, I suspect you likely imagined an actual factory that somehow manufactures data, but it's actually not that far off. From a definition perspective, the data factory takes raw data sources as inputs and, through a series of orchestrated steps, produces analytic insights that create value for the organization. Put it in a bit of context, if you think about an actual factory floor, you can take multiple parts, transform them, mold them together, and ultimately produce an end product to deliver to customers for their use. You may have multiple production or manufacturing lines that are handling different parts. And sometimes each of these lines is actually simply creating interim products, which will then ultimately come together and create a single end product. A data factory isn't dissimilar to this idea. Conceptually, you take multiple data sources, transform them, mold them together, and ultimately produce an end product to deliver to your customers for their use. You can have multiple data pipelines handling different data sources, and sometimes the pipelines are creating interim models that are ultimately joined to create a single robust data set, for example. So the term data factories does, in fact, compare data pipelines to lean manufacturing lines. A key aspect to lean manufacturing is called a statistical process control, or SPC. SPC is the application of real-time process quality monitoring using statistical methods, and it was first introduced in the 1920s by Bell Labs. What it does is provide proactive as opposed to reactive identification of inputs and process issues. But how does SPC apply to a data pipeline, you may be asking yourself. If you envision your data pipeline as a pipe, as we have here on the slide, you'll feed it data, run a series of steps to, say, land, process, restate, transform, enhance your data, et cetera, and then ultimately produce a data set to be used by your end users, whether they're business analysts, data scientists, et cetera. And what they'll do is actually use that end data set for further analysis and some of their decision making. You can ultimately incorporate monitoring checks intermittently throughout the pipe. Maybe you'll just have those checks after heavy transformations, maybe you might do it as frequently as every step of the way. The expectation is when a monitoring check passes, the data will continue to flow through the pipe over to the next step. However, when a monitoring check does not pass, the pipeline stops, preventing inaccurate data to flow through to your end users. Now, this is beneficial for multiple reasons. If an upstream step produces inaccurate results, which might only be checked at the end of a process, you will have likely run downstream steps that did not need to be run, and will then likely need to be run again once your intermediate step is fixed. If you consider cloud architecture that invoices you based on uptime and processing, what that means is you're spending more money when you allow inaccurate data to continue flowing through your pipe, rather than stopping it earlier for investigation. Further to that, once you do find an issue in your pipeline, by having these interim monitoring checks, you can more easily identify the particular process or even line of code that may have caused the issue. So not only does SPC ensure your end users are only seeing correct data, but it eases the strain on your IT team in their ability to quickly find and fix a bug. There are a multitude of monitoring methods that can be used on your data pipeline. They can be as simple as row counts, maybe full measure aggregates. You can check null percentages or expected data formats for various fields. You can get as complex as variance against previously observed data or variance against predicted data based on previously observed data. What you see on the slide here is just a small sampling of the methods you can use, but are illustrative of the types of activities you can choose from. I will say when you do look at choosing your monitoring method or methods, it's important to weigh the complexity and the investment in building the test against the incremental accuracy of that test. For example, if you're looking to create a variance versus prediction test, that might take significantly more time and effort than something more simple like a row count or measure aggregate test. So if all that additional time and effort creates results that are maybe 75% more accurate, perhaps you make that investment. However, if all that time and effort only produces results that are 2% more accurate, and 2% in the context of your system is pretty minimal, then perhaps you don't make that investment. It's also important to weigh the potential method in the context of the other tests you have in the pipeline. You can use a variety of methods within a single pipe, and the combination of those can produce more accurate results. There are generally three types of issues that can be identified with SPC on your data pipeline. The first deals with inaccurate data at the outset. If your first data monitoring step checks if your landed data is accurate and it fails, there has to be an issue with the data inputs themselves. If you're pulling data from, say, Salesforce, and one of your business users within the Salesforce app had a typo in an account name, you may need to consider how to automatically account for such user errors. If you're purchasing data from a third-party vendor and a product is mapped incorrectly, you'll want to reach out to that third-party vendor immediately to remedy the situation. A second type of potential issue is when you've confirmed your inputs are good, but your end output looks to be a bit inaccurate. This usually indicates something's gone awry within the pipeline itself. And as mentioned previously, the earlier you identify the inaccuracy, the easier it is to identify and fix. And finally, the most complex of the types of issues is when you know your pipeline is working as expected. Maybe it's been in steady state for a number of months. And you've also checked off that the data inputs seem fine, but nonetheless, your end output looks to be pretty off. What this usually indicates is what is called a data shift. Now, this is what happens when something's changed about your input data and is thus different from an initial data sample that you use to define what you check your input against. It usually results in a need to change business logic within your process to account for said data shifts. I will say it is a pretty tricky concept and requires a great deal of data expertise to quickly identify and to mitigate. So if you do have more questions about data shifts, do reach out and let us know. But overall, the expectation is that data factories allow you to manage, measure, monitor, and control your data pipelines in real time. So let's pivot to our last buzzword of the day, which is DataOps. Direct from Wikipedia, DataOps is an automated, process-oriented methodology to improve the quality and reduce the cycle time of data analytics. DataOps applies to the entire data lifecycle, from data preparation to reporting, and recognizes the interconnected nature of the data analytics team and information technology operations. Some people argue that DataOps is simply DevOps for data. And yes, it's easy to think that, especially considering the similarity in their names themselves. It's also, to be fair, a quick and easy way to sound like you know what you're talking about. And while DataOps does incorporate some of the lines of thinking as DevOps, it is a bit more nuanced than simply DevOps for data. We're seemingly starting with something they have in common, but DataOps, similar to DevOps, does have its own manifesto available online. There are 18 principles within the DataOps manifesto. We won't go into the details of all 18 of them on today's webcast. You are free to check out the manifesto yourself at dataopsmanifesto.org. But I did want to call out 3 principles in particular, and you'll get a sense of why I chose these 3 in a second. Analytics is manufacturing, quality is paramount, and monitor quality and performance. The first, analytics is manufacturing. This principle kind of reminds you of data pipelines, right? It even explicitly states that comparison to lean manufacturing lines and the intent to achieve continuous efficiencies. The emphasis is my own. Quality is paramount. This looks to incorporate anomaly detection and provide continuous feedback to those responsible for operating or owning the data system. Monitor quality and performance. And this incorporates the need to not just continuously monitor the data quality itself, but also the health of the data system, including end-to-end performance and data latency. It may be obvious why I called out these 3 principles. We've literally just spoken about data factories, and data factories in and of themselves already seem to have these 3 principles embedded. But also, I wanted to point out a pattern with the use of the word continuous, or derivation thereof. Alaistair touched upon continuous integration and continuous delivery, referred to as CI/CD, in his DevOps section. This continuous monitor, control, and feedback loop for data within the DataOps methodology is quite similar to CI/CD within the DevOps methodology. So if DevOps can optimize the actual delivery of, say, a business intelligence system using things like automated testing, CI/CD, and infrastructure as code, data factories look not necessarily at system delivery, but at data quality and its delivery. I like to refer to it as the operations behind data. What DataOps is, it looks to tie both of these 2 concepts together to provide accurate and efficient data analytics. I will say some folks also include a 3rd input to DataOps for Agile, with capital A, Agile methodology. I would say that there is agility that is inherent within both DevOps and DataOps, DevOps more explicitly so. Standing up and running data factories can be done with agility. For example, you can produce a data pipeline with just a few transformations to get it out to the business quickly, and then add more business logic over time as you receive that continuous feedback loop from your end users. You can add SBC steps over time as well. So I don't see strict Agile methodology itself as a requirement for the success of DataOps, but rather an aspect of both of its 2 inputs. Why bother with DataOps? How can it help manage your data systems? To recap, DataOps combines the optimization of code delivery via DevOps and the ongoing monitoring and maintenance of data through data factories to continuously add value to data-rich self-service systems and end-user reporting. There are a multitude of benefits to adopting DevOps. It increases your on-time delivery over time. The more you run it, the more efficient you can make your process, the more that can be automated, the better your metrics. Errors in production will decrease over time. Similarly, the more you run, the more you can identify items to be fixed. Enhancements to the systems can be rolled out faster and faster. If a business user comes looking for a new field or a new KPI to be added to an end report, the more testing, automation, and governance within your system, the easier it will be to deliver and enhancements. And with the monitoring and control aspects of data factories, your analytics become more accurate and more reliable. And you very well may know, at the end of the day, your business intelligence system is only valuable if your end users actually use it. There is a risk I wanted to call out with the adoption of DataOps, and it's the potential to add process, but losing agility. I've seen companies adopt agile methodologies, or DevOps in particular, that lose sight of the purpose of the new way of working and actually just add process and documentation for the sake of process and documentation. It sometimes even becomes counterproductive and extends timelines for delivery or makes it difficult to enhance the product for the business. So it's important to be mindful of the purpose of adopting a new methodology, and in this case, it's to deliver quickly and to deliver well. So where do you go from here? Well, you can join meetings with your colleagues later today. You can casually mention DevOps, DataOps, showcasing your newfound knowledge of these terms. You can take it a step further, actually be an advocate or champion within your organization for the adoption of any of these concepts. Perhaps you can even lead an initiative to take an existing BI system and transform its operations accordingly to prove out the model. But always learn more. There's a ton of content out there, and we only touched upon some high-level concepts of each of these three terms, so we're also here to help answer any of your questions. And that's a wrap. Thank you to everyone for joining today's webcast. If you have any follow-up questions, please don't hesitate to reach out to myself or Alaistair at the contact details we have on the screen here. We are easiest to reach over email or LinkedIn, so please don't be shy. And thanks again. Have a great rest of your day.